Ultimate Factoring Series, Lesson 8, Solving by Factoring. This is the final lesson in the Ultimate Factoring Series. So now you know how to factor, but all we've done is simplify by factoring, basically. So what happens when you need to factor to solve an equation? So a fair question to ask is, how do I know when to solve by factoring? You've learned to solve for x for probably a long time now. How do you know when you're supposed to factor instead of just do the normal solve for x kind of a deal? Well, the key is when you see variables that have different exponents, it's probably a good sign that you need to factor. So if you look at these examples, if you look at the example in red, 3x plus 4 equals 7 times x plus 1. Both of the x's have the same exponent. So the variables have the same exponents, so I would not need to factor this one. I could just do the normal solve for x, get x by itself kind of a process. If you look at the blue one, I have a 9m squared and a 5m to the first. Now that signals to me that I have different exponents, and it would probably be a good idea to try to solve that one by factoring. Now the black example, 3k squared plus 7 equals 4k squared. They have the exact same exponents on both the k's, so since the exponents are the same, there really shouldn't be a need to factor. Finally, the green example, I see that I have an a cubed, I have an a to the first, I have an a squared, and I have an a to the first. Since I have different exponents all over the place, that's a good sign that that would be a problem good for factoring. So the trick to knowing if you need to factor or not is looking at the exponents. If you see different exponents floating around, there's a good chance that you need to factor. So here are the steps to solving by factoring. Now some of these steps may already be done for you, but if you follow these 4 steps, or at least check that these 4 things are done each time, you should be good. So first thing is you need to set the equation equal to 0. The second thing is you need to make the biggest exponent positive. So whatever the biggest exponent is, it might be a squared, it might be a cubed, it might be anything, you need to make sure it's positive. You can accomplish that if it's negative. You can fix that one of 2 ways. You can either just move everything over to the other side, add or subtract to get it on the other side of the equation, or you can multiply everything by -1. Both will accomplish the same thing, so that's completely up to you. Number 3 is to factor out the greatest common factor if there is one. And number 4 is to factor, and that could be using any of the methods you've learned in lessons 1 through 7. Could be difference of squares, difference of cubes, sum of cubes, using trinomial methods, box method, guess and check, factoring by grouping, bottoms up, any of those methods. So this is where you apply everything you've learned in the other videos. So you see the difference between these examples and all the ones in lesson 1 through 7 is lesson 1 through 7 didn't have equations. Now we're looking at equations where we're trying to solve. So the fact that I see an x squared and an x to the first tells me that I should probably factor because there's different sized exponents. And since there's 3 terms, I know it's a trinomial, so I'm going to set up 2 parentheses. This is a problem just like the ones you learned about in lesson 5. So I put the x's out front, and I need to think, okay, what will multiply to be -12, and what will add up to -4? Well, the terms for 12, 1 and 12, 2 and 6, 3 and 4. Looks like 2 and 6 is my best candidate. A +2 and a -6 would add up to a -4, and a +2 and a -6 do multiply to be -12. So I put a +2 and a -6. Now, in the other lessons we would be finished because we factored. But for this lesson, we're not done. We have to solve for x. Here's the reason you have to make sure things are set equal to 0. There's a property of 0 that says if A times B equals 0, then either A equals 0 or B equals 0 or both. So if either piece, either x plus 2 or x minus 6 equals 0, then the whole thing is 0. Since 0 times anything is 0, if any one piece is 0, the whole thing is 0. So once you get factored, the last thing you need to do is take both pieces individually and set them equal to 0. So here I just subtract 2 from both sides. I get x equals negative 2. Here I add 6 to both sides, and I get x equals positive 6. So my answers are x equals negative 2 and x equals positive 6. And you're welcome to check these. If you plug negative 2 back in for the x's, you should get 0. Or if you plug 6 back in for the x's, you should get 0. Okay, now I skipped talking about my 4 steps, so let me make sure we go through them this time. Step 1, set equal to 0. Check, that's already done. Step 2, make sure the biggest exponent has a positive coefficient. Check, that's already done. The t squared is positive. Number 3, check for the greatest common factor. Is there anything that all the pieces have in common? Nope, in this one there's not, other than 1, which that doesn't help us to pull that out. So then we go to factoring. Since it's a trinomial, what makes the most sense is to set up my 2 parentheses. I'll put t's out front. I need to find something that multiplies to be negative 10 and adds up to negative 3. So the things that multiply to be 10 are 1 and 10 and 2 and 5. So 2 and 5 would seem to be my candidates to add up to a negative 3. To get a negative 3, I would need a positive 2 and a negative 5. Positive 2 and negative 5 also add up to multiply to be negative 10, so that works out. So I'll have a positive 2 and a negative 5, and I know that that is equal to 0. So this is the new part. Once you get them factored, you need to take both pieces individually and set them equal to 0. Because if either one of them is 0, then this will work. Subtract 2 from both sides, you get t equals negative 2. Add 5 to both sides, you get t equals positive 5. So you get 2 answers for this. And just in case you're very, very new to this, it can also just be written this way. You can say t equals negative 2 and 5 just by using a comma in between if you want. Okay, so now let's think carefully through the 4 steps I gave you. First step, get it set equal to 0. Right now I don't have this equation set equal to 0. To do that, I'm going to subtract 16x from both sides and get 2x squared minus 16x equals negative 30, and then add 30 to both sides. Now you may be asking yourself, why did I move 2 pieces over when I could have just moved the 2x squared over that way and just had to move 1 piece? The reason is because of step number 2. I want my biggest exponent to have a positive coefficient. Since this was already positive, I wanted to leave it where it was because I wanted it to stay positive. If I had subtracted it over to the other side, then I would have made it negative and I would have had to fix that, so I really wouldn't have saved myself any time. So step 1 and step 2 are covered because I have set it equal to 0. I have made sure that the biggest exponent has a positive coefficient. So the next thing to do, step 3, is to look for the greatest common factor. Is there anything that all 3 of the pieces have in common? And in fact, yes, there is. Every single one of those pieces has a 2. So if I pull 2 out front, it leaves me with this. Now what I have inside is a trinomial. So with a trinomial, I want to set up my 2 parentheses, put x's in front. Don't forget to leave the 2 out front, okay? Don't drop that 2. And I need to find things that multiply to be 15 and things that add up to negative 8. So that would be, let's see, 15 can be 1 and 15 or 3 and 5. So a negative 3 and a negative 5 adds up to a negative 8. A negative 3 times a negative 5 multiplies to be positive 15. So both of those work. X minus 3 and x minus 5. Now that we have it factored, we need to set each piece equal to 0. Well, 2 equals 0 actually doesn't make any sense. So if there's no x, you really don't have to worry about it. It's not going to affect your final answer. So the 2 doesn't give us anything. X minus 3 equals 0 and x minus 5 equals 0. We add 3 to both sides and get x equals 3. Add 5 to both sides and we get x equals 5. Okay, once again, we need to follow all of our steps. Step 1, get it set equal to 0. Well, like I said, I know what step 2 is. I know step 2 is that I want my biggest exponent to have a positive coefficient. So since it's already positive, I personally would choose to subtract 3x from both sides. Because then step 2 is already done for me. I have a positive coefficient with the biggest exponent. Step 3, look for the greatest common factor. What do 6x squared and 3x have in common? Well, they have a 3x in common. That'll leave them with 2x minus 1. And that's actually as far as I can factor. So there's nothing more to do once I factor out my greatest common factor. So now is when I set both pieces equal to 0. Here I just divide by 3 and get x equals 0. Here I need to add 1 to both sides and then divide by 2 to get x equals 1/2. So these are my two answers. Now I want to pause here and talk about these terms because this throws people off a lot. People say, okay, well wait a minute, in the last problem you just said the 2 doesn't matter, but in this problem you did use the 3x. So let me try to explain again why that matters. Back here, the 2 had no x. Since there was no variable involved, there's nothing we could do. When we set that equal to 0, we just got 2 equals 0, and last time I checked it doesn't. So that makes nothing. But we do have an x with this one, and that's the difference. 3 times 0 is 0, so 3x can equal 0. So if it's just a number, it really doesn't matter. But if it's a number with a variable, then it does matter. So whether or not you have an x is what makes the difference. If you have an x, you've got to use it. Okay, next one. We need to get this set equal to 0. Well, honestly, before I even bother with that, I'm going to go ahead and distribute what I see there so I can start simplifying. 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Okay, step 1, we want to set it equal to 0. I'm going to subtract 5x cubed from both sides. Gives me negative 3x cubed. And I'll add 7x squared to both sides. That gives me negative 3x cubed plus x squared equals 0. So I've covered step 1. I simplified and I set the equation equal to 0. Step 2 is I need to make sure that my biggest exponent has a positive coefficient, which right now it doesn't. My 3x cubed is the biggest and it's negative. So I'm going to multiply both sides by negative 1. Negative 1 times negative 3x cubed is positive 3x cubed. Negative 1 times positive x squared is negative x squared. And then 0 times anything is just 0, and that is multiplying. So I've done step 1 and I've done step 2. I've set it equal to 0 and I've made sure my biggest exponent has a positive coefficient. Step 3 is take out the greatest common factor. Both of those have an x squared, leaving me with 3x minus 1. And that's actually as far as I can factor it. There's nothing more to do. So I can at this point set both pieces equal to 0. Here I just square root both sides and I get x equals 0. Here I add 1 to both sides and then divide 3 to get x equals 1/3. 3x cubed minus 2x squared equals 8x. So one thing I've been forgetting to remind us of, the way we know these need to be factored is the fact that we have different sized exponents. We have a cubed, we have a squared, and we have a to the first. So I go through my steps. Set it equal to 0. Well, I'll subtract 8x from both sides and get 3x cubed minus 2x squared minus 8x is equal to 0. Step 2 is already good because the biggest exponent has a positive coefficient. It's positive 3x cubed. Step 3, look for a greatest common factor. They all have x in common. That leaves me with 3x squared minus 2x minus 8 equals 0. Now, this inside can be factored further, which is why we have a step 4. Factor more if you can. This is like lesson 6. So I know there are 3 different methods you could use for lesson 6. So you may not like the method I choose right now, but I'm just going to go with bottoms up. So with bottoms up, I know I need to put an x out front with both of these. I need to multiply 3 times 8, which is 24. I need to multiply to equal 24, and I need to add up to negative 2. So 24, and excuse me, that should be a negative 24 we multiply to be. 24 is 1 and 24, 2 and 12, 3 and 8, or 4 and 6. So 4 and 6 are my best bet to get the negative 2, and that's going to need to be a positive 4 and a negative 6. And that is successfully multiplying to be negative 24 and adding up to negative 2. So I put a positive 4 here and a negative 6 here. And then, because it's bottoms up, I have to divide by the number out front. So divide by 3, divide by 3. Here, 4 over 3 does not reduce, so I take the bottom up and get 3x plus 4. Here, 6 over 3 is just 2, so there's no bottom left to bring up. So now I'm finally done factoring, and now I can set each piece equal to 0. So I'll do x equals 0. Well, that's already done for me. That's nice. 3x plus 4 equals 0, and x minus 2 equals 0. So subtract 4 from both sides, and divide both sides by 3. And on this last one, just add 2 to both sides. Whew, so this one has 3 answers. X equals 0, x equals negative 4/3, and x equals 2. If you wanted to check this, you could go back to the original right here and plug 0 in for all of them. You'd get 0. Plug negative 4/3 in for all, you should get 0. Or plug 2 in for all of them, and you should get 0. Okay, so again we know that this should be, we should solve this by factoring because of the different sized exponents. We need to set this equal to 0 because that's our step 1. Subtract 1 from both sides. Step 2 is taken care of. The biggest exponent has a positive coefficient with it. Step 3, there is no greatest common factor. So step 4 is to factor. Well, since I did bottoms up last time, we'll do guess and check this time. This is one like lesson 6. We have a coefficient other than 1 in front of x squared. So let's use guess and check this time. The only way to get 2x squared is to put a 2x and an x. Well, and the only things that multiply to be 1 are 1 and 1. So the only thing I really have to do is figure out my signs. Let's see, 2x times 1 is 2x, 1 times x is 1x. And I want this to add to a negative x, so that means I need it to be a negative 2. So it needs to be 2x times negative 1 and positive 1 times x. Now that I'm factored, I can set both pieces equal to 0. Subtract 1 from both sides. Divide both sides by 2. I get x equals negative 1/2. Add 1 to both sides, and I get x equals 1. Final example. We know that this is going to be a problem where we need to factor because we see exponents of different sizes. My first step is to set everything equal to 0. So I'm going to subtract 16v squared from both sides. I get 6v cubed plus 21v minus 16v squared equals 56. Then I will subtract 56 from both sides. I get 6v cubed plus 21v minus 16v squared minus 56 equals 0. Just so you know, there's nothing mathematically wrong with the way I have this written, but we usually we usually do write the variables in order. In other words, the biggest variable, biggest exponent first, and then work our way down. So these two are kind of out of order, so I'm going to swap them and make it 6v cubed minus 16v squared plus 21v minus 56 equals 0. Now I kept their signs that you have to when you swap them, but that is the exact same thing because I'm just putting the same thing in a different order. Since we have 4 terms, that should set off a signal in your mind to use factoring by grouping. Actually, let's just go through our steps here. We got step 1 done. It's set equal to 0. Step 2, the biggest power is positive. Step 3, there is no greatest common factor. There's nothing all 4 have in common. So we come down to our last thing, which is to use factoring by grouping. So I'll group these in 2 pair. 6v cubed and 16v squared. I believe the biggest thing they have in common is a 2v squared. That leaves me with 3v minus 8. And 21v and negative 56 both have a 7 in common. That leaves me with 3v minus 8. Both of those terms have 3v minus 8. So I can pull 3v minus 8 to the front. That leaves me with 2v squared plus 7. And don't forget, you should be writing equals 0 on this. Sorry about that. Now that we're completely factored, we can set both pieces equal to 0 to find our answer. Add 8 to both sides. Divide both sides by 3, and I get v equals 8/3. Now we're actually going to get an interesting result over with this one, so pay close attention. Subtract 7 from both sides. 2v squared equals negative 7. Divide both sides by 2, and I get v squared equals negative 7/2. Well, my next step would be to take a square root, but I cannot take the square root of a negative number. So that means there's no way to make this piece equal 0, and we just have one final answer. So keep in mind, if you get square root of a negative, that means that won't work. So this piece does give me an answer, this piece does not. There's nothing wrong with what we did, it's just that this is the only piece that can actually equal 0, and it gives us the answer, v equals 8/3. Thank you very much for watching. I hope this is helpful to you. Please feel free to leave comments to help me know how I can improve this for you in any way.